All right, in 5.4, we're going to look at what happens when you solve a system of equation, whether it be graphing, substitution, or elimination, and you get a special solution. So let's take a look at what I mean. So as we've been solving these, whether it's graphing, substitution, or elimination, our goal is to figure out what is that value of x, what is that value of y. We talked about every time that represents a point. And going back to the very beginning, ideally what we're looking for is on a graph, what is or where is that point where those two lines would intersect? Because system of equation, we're just giving two linear functions. And by solving them, trying to find that common intersection point. Now, given that they're lines, here's some special things that occur. Sometimes when you graph two lines, they're parallel. Parallel means that they will never, ever intersect. So if two lines are parallel and don't intersect, how could they have a solution if they don't have a point where they intersect? So if lines are ever parallel, what that means is that there's technically no solution. There's no one point that they have in common. Similar to that, but kind of opposite, is instead of having two lines that are parallel, what if the lines are the same? So let's say that I have, this is kind of tough to see, but let's say I have a red line drawn here, and then I have a green line drawn on top of the red line. They are the same line. Same line, now they might look a little bit different, but they technically are the same, and I'll talk about what that might look like. If that's the case, if two lines are technically the same line, well then they intersect not at one point or no points, but they intersect at every point, which means not that there's no solution or one solution, but there's infinitely many solutions. So what we're going to try and do today is solve systems of equations using our methods we learned and identify these special cases. So let's take the first one. Look at graphing. So this is from section 1. Again, graphing, we're going to try and plot these two lines in our graph and figure out where they intersect. So here I'll show in red, I have the 2x plus 1. I'm going to start at plus 1, my y-intercept. My slope here is 2, which if you remember is 2 over 1, which means I'm going to go up 2 and over 1 from that point. So I would have a couple points there, and I'll go down 2 over 1 on the left, and my line would look something like this. Ooh, not the prettiest, but that's okay. My blue line, I got 2x minus 5, so I'm going to start at minus 5, and I'm going to do the same slope. Whoa, wait a second. Its slope is also 2, which is also 2 over 1, which also means up 2 over 1. So you'll notice here that if I plot a couple points, go up and right and down and left, and I were to draw this line, well, wait a second, Big Daddy Dollars. What's going on there? Well, those two lines are not going to intersect. These two lines are said to be parallel. Okay, why are they parallel? Well, it goes back to something we learned about a while back, is that notice they both have the same slope of 2. So if I have two lines that are parallel, what that means in this case is that there is no solution to this problem. Those two lines are parallel, they do not intersect, so there's no value of x or y that would make both these true. All right, next let's look at substitution and elimination. So substitution, again, what we're looking for is we're looking for an equation that says x equals something or y equals something. And we're going to take that and plug it in to the other equation for our variable. So notice in my second equation it says y equals 3x minus 1. So I'm going to take this expression right here, 3x minus 1, and I'm going to plug it into the first equation where I see y. So I'm going to substitute that in, replace. So my first equation would become this. It'd become 3x minus 1. I'll put that in parentheses. Minus 3x equals 2. Now there's no number in front of the y, right? There's no number in front of the parentheses. So those parentheses are really kind of useless. So I have 3x minus y minus 3x equals 2. Now notice when I have my x's and I'm going to gather them together, they're both on the left side of my equation. I have 3x and minus 3x. So what happens? Well, they're on the same side. And notice that they're equal and opposite. So what ends up happening if that they're equal and opposite on the same side and I add them as is, they cancel out. And what I'm left with is negative 1 and on the right side 2. Now notice in this problem, what I'm trying to solve for, x, eliminates. It cancels itself out, which means I can't solve for x. So this means one of two things. This means, like the last problem, there's no solution, or this tells me that there's infinitely many solutions. So this, what's left behind is called an identity. In this case, this identity is not true. Negative 1 is definitely not equal to 2. And because it's a not true statement, that means there is no solution here. Okay, so no solution, again, if there is a statement left behind that's not equal. Now, x canceled out, same thing would have happened with y. Y would have canceled out, and again, I would be left with a statement that's not true, so that's no solution. Next, we're going to solve by elimination. So elimination, we are looking for equal and opposite. So if I have, let's say, 3 and -3 or whatever it might be, this one I don't see equal and opposite, so what that means is I might have to modify my equation a little bit. So let's say I make the x. I want to eliminate the x's. I have x and 3x. So in order to eliminate, I'm going to have to multiply this first equation by some number, okay? And I want it to be equal to 3x. So that means I'm going to have to multiply it by 3. But I also need it to be the opposite, so I'm going to multiply it by a -3. So I'm going to take everything in here and multiply it by -3. And here's what I would get. I would get -3x plus 9y equals -18. Okay, multiplied everything by 3. Bottom equation I don't have to change, so that would just all stay the same. And now when I solve this by elimination, by adding these together, watch what happens. Whoa, -3x and 3x. Those cancel out. 9y, -9y. Whoa, cancel out. 18 and -18 cancel out. Whoa! Everything cancels. What's left behind? 0 equals 0. There's nothing left behind on both sides. Now, just like the previous problem, everything I'm trying to solve for, x and y, canceled. So that means one of two things. No solution or infinitely many solution. How do I know? Well, what's left behind? 0 equals 0. Well, wait a second. 0 certainly does equal 0. Hey-oh. So if the statement that's left behind is true, that means there is infinitely many solutions. Okay, infinitely many solutions. Or you could also say all real numbers. Anything would work if I plugged it in. So again, what we do is when we solve this as a special case, it's not going to happen every time, but it's a special case when those variables eliminate each other. All right, last problem here. I want you guys to try this one on your own. So pause the video, try this one. It says solve using any method. Let's put you to the test. Now, obviously, I don't give you a graph, so there's a little hint, hint, nudge, nudge. I'm not saying you can't graph this, but you could. But I want you to solve this using any of the 3 methods and see what you get for your answer, okay? Pause the video, give it a shot. Alrighty then, so I decided to solve this by substitution. I recognized y equals -10x plus 2, so I saw y equals, and I said, hey, that looks like a substitution type problem. So I took that -10x plus 2 and I substituted it in for y, replaced y, and I got 10x plus -10x plus 2 equals 10. A lot of 10s there. Then looking, 10x and -10x. Well, wait a second. Those cancel out, leave me with 2 equals 10. Well, 2 equals 10 is not a true statement. So because of that not being an equal statement, I knew right away that's no solution. So again, solving this doesn't matter what method we use, but we're looking at it. What happens when the variables we're trying to solve for cancel each other out? And that's going to leave me with an identity or statement that's going to tell me whether there's no solution or infinitely many solutions. All right, hope you guys enjoyed. We'll see you next time. Bye now.